Fair enough. Now this video is to find out why do we have a sine theta term in the magnitude of cross product. Fair enough. So we will like to first begin with this. We consider two vectors, A vector and B vector, in two dimension. So if you're considering them in two dimension, what can you write? A vector as I cap ax plus j cap ay. That means you're considering them in the xy plane. And B vector as I cap bx j cap by. Okay, now first things first, we would like to find out the cross product. So we have A vector cross B vector as, we will have I j k ax ay, no z component, 0. Then we have bx by, no z component, 0. So this works out to, I will be of course, so we have I cap 0 coefficient minus j cap 0 coefficient plus we have k cap, what do you get? Ax by minus ay bx. So therefore, if you would want to find out the magnitude of A cross B, so what would the magnitude of A cross B be? It is going to be the square root of the square of the coefficients. So we have the coefficient over here as 0, so 0 squared plus 0 squared plus we have ax by minus ay bx the square. Okay, so let us square both the sides. One second. So on squaring both the sides, we will write magnitude of A cross B the square, which is going to be equal to ax by minus ay bx the square. Simplifying this would be equal to ax squared by squared plus ay squared bx squared minus 2 into ax by ay bx. So we will call this as equation number 1. Please remember this, we are going to use this later. Or in fact, I'm going to rewrite this so that it is pretty clear to you. So therefore, we are going to write this as A cross B magnitude square is going to be ax squared by squared plus ay squared bx squared minus 2. I'm going to rearrange this and write this as ax ay bx by. That is equation number 1 and we will box that. Fair enough. Now I hope you also remember that also we know that magnitude of A cross B can also be written as A B sine theta, and this is what we are trying to find out. How in the world is this equal to this? Okay, so equation number 1 done. Let us move ahead. Now let us consider these two vectors and take a dot product of these two vectors. So we have A vector dot B vector, that you can write as A B cos theta. Also, if you remember, we can write a vector dot b vector as I cap ax plus j cap ay dot I cap bx plus j cap by. Now I dot I is equal to 1, I dot j is equal to 0. So this and this would remain, j and j would remain, I and j and I would vanish. So therefore we can write a dot b also as, if you remember, ax bx plus ay by. So rewriting this, we are going to write this as a vector dot b vector, which is equal, from here we are just rewriting this. So we have this as ab cos theta, and that from here we can write as ax bx plus ay by. Okay, now just consider this and square both the sides. So squaring both sides, we will get a square b square cos square theta would be equal to ax bx plus ay by the square. So expanding this, that would be ax square bx square plus ay squared by squared plus 2. We have ax ay bx by. So we have ax ay bx by. So rewriting this properly, we have therefore a squared b squared cos square theta. I'm going to rewrite this as a x squared b x squared ay squared by squared plus 2 ax ay bx by. We will call that as equation number 2. Now I would like you to see, there you are, equation number 1. Equation number 1, left hand side we have magnitude of a cross b the squared. Right hand side, I'd like you to focus here. Do we have a minus 2x ax ay bx by? And if you see equation number 2, on the right hand side, do we have a plus 2 ax ay bx by? So we are going to simply add 1 and 2. So adding equation 1 and equation 2. So when you add that, you will get magnitude of a cross b the squared plus a squared b squared cos square theta. Okay, now over here we will add this to that, because the 2 ax ay bx by term will vanish. So it will become, we're rewriting this, we will have ax squared by squared plus ay squared bx squared plus we have ax squared bx squared plus ay squared by squared. Now over here we will take ax common, so I'm going to take ax square as common. So when you take ax square as common, you have that and you have that, so you will have bx square plus by squared, and then you will take ay common, so we have ay squared, and that will be into bx squared plus by squared. This obviously, if you agree with me, would be ax squared plus ay squared into bx squared plus by squared. Okay, so I'm going to rewrite this. So thus what you get, one second, we have magnitude of a cross b the squared plus a square b square cos square theta is equal to, we have ax square plus ay square into bx squared plus by squared. Now we're going to play with this in a short while. That is your equation number 3. But before we go ahead with equation number 3, we have a small note that I'd like you to, of course you know this, but if you have a vector as I cap ax plus j cap ay, then if you remember, the magnitude of a vector, which you normally write as a, that would be under root of ax squared plus ay squared. So from here, does it follow that a squared is equal to ax squared plus ay squared? Similarly, you can write b squared as equal to bx squared plus by squared. So using this result in equation number 3. So using this in equation number 3, we can write, we will write a cross b the squared plus a square b square cos square theta will be equal to a squared b squared. Playing with this, so we have a cross b the squared would be a squared b squared minus a squared b squared cos square theta. We have a square b square as common, so we have 1 minus cos square theta. This is obviously 1 minus cos square theta is sine square theta. That is a basic trigonometric identity. Sine square theta plus cos square theta is 1. So we have this as sine square theta. Removing the squares on both the sides, thus voila, we have our result. A cross b, the magnitude is equal to a b sine theta. That is the result that we were looking for. That is how you get a sine term in the magnitude of a cross product. Clear? Okay. Apart from this, of course, the magnitude here also represents the area of a parallelogram. Now, how does it represent the area of a parallelogram? That in a short while. Say for example, you have two vectors acting along the adjacent side of a parallelogram. So this is a vector, we will call that as a vector. This is another vector, we will call that as b vector, and the angle between the vectors is theta. It will be theta. And so what over here is the area of the parallelogram? First of all, the magnitude of a vector is a and the magnitude of b vector is b, and let us say that this over here is the height of the parallelogram. So what is the area of the parallelogram? The area of the parallelogram A is the base into the height. So what is the base into the height? Magnitude of a vector, which is a, into the, I will not write into as cross sign over here because you may confuse that with the cross product. So we'll write that as a, and the height I will write as h. Now using basic trigo or trigonometry, can you write, since h by b is sine theta, so therefore what is h equal to? B sine theta. So therefore, can you write the area as a b sine theta? So when you are writing the sine product and the cross product and the magnitude of the cross product which you write, that means if you have two vectors a cross b, then the magnitude of a cross b is a b sine theta. Then a b sine theta not only is the magnitude of the resultant of this cross product. Let's say the resultant of this cross product is c vector and the magnitude of this is a b sine theta, but that magnitude also, that means this also represents the area of the parallelogram formed by a vector and b vector. So that is it. That is how we, or why we have a sine term in a cross product, and what does the actual product represent. Okay, I hope you've understood that. Thank you very much. Bye bye.